Okay, so today we'll talk about our next chapter, which is chapter 3, decimal fractions. Last class we talked about the fraction, so which has a very close relation with the decimal fraction. So let's start with the same, page that every number, every digit in a number has different contributions like these, based on the position, right? So even if we have all these ones in the number, but each one has a different contribution. Like here, this one is only 1, but this one is 10, right? This one is 100, 1,000, 10,000. Similarly, if you go to the right side of the decimal point, then it gets decreased every time you move right? So for an example, this is 1/10, this is 100, right? This is 1/1000, this is 1/10,000. So similarly, for an example, if this is your number, since you have different digits in different position, so we can calculate the weight of each digit. For an example, 5 is in 10,000 positions, so we multiply 5 by 10,000, 0 by 1,000, 3 by 100, 1 by 10, 5 by 1, and then we add all of this. We get the number again, because each digit is contributing differently. This is another example where we have some digits after the decimal point, and we can do the same. But remember, if you go to the right, it's just getting decreased every time. But sometimes you have noticed that we have zeros which does not contribute anything to the numbers, but still 0 is important because it's used as a placeholder. Because of the 0, you can keep the other digits in the right place. So in some cases, zeros are quite important. Not probably in every case. For example, here, 0 between numbers, of course, are quite important. And between numbers or between a number and a decimal point changes the value of the number. For an example, let's say, you see here, this 0 is quite important, right? Because otherwise the number 405 becomes 45, right? Without this 0. And same is here. You see, this 0 is basically changing the whole number to much lesser than these. Like 0.62 is much higher than 0.062. And that happens just because of this 0, because this 0 is changing the position of 6 and 2. Right? But in some cases, like this one, the 0 does not have any value, like this. For an example, if we have a 0 to the left of a whole number, for an example here, this 0 does not have any contribution, it doesn't make any difference. So, yeah, of course. So, and 0 to the right of a decimal does not have any value as well. But remember, that's only true when 0 is at the right side and there is a decimal point before that. Then it doesn't matter. Okay? 0 to the left of a decimal point does not change the value either. But in most of the cases, we use this 0. This is a convention because sometimes people does not look at the decimal point unless you place a 0 and then place a decimal point. But otherwise, these two numbers have the same value, no difference. So this is what we said. So rules of the significant figures, because of the zeros and other digits, they have different positions. So we have to identify which digits are the significant digits or significant figures in the numbers. For an example, the significant figures follow in consecutive place value next to each other from left to right. So pretty much all these are significant. Non-zero numbers, of course, always significant no matter what. Zeros are significant if is used as a placeholder between any two 0 numbers. For an example here, all these zeros are important because if you just remove one of the zeros, all this number will be changed. So all these zeros are important because these are between other two numbers, other two digits, or between one digit and one decimal point. These are quite important. They are significant as well. And zeros at the end of a number to the right of a decimal indicate exactness sometimes, because in some of the scientific calculations we do this, but that's probably not all the time. In some cases, zeros in front of all non-zero numbers are not significant at all, like these ones, because this zero doesn't make any difference. These two zeros doesn't make any difference as well. And zeros at the end of the non-zero numbers and ending to the left of a decimal point may be assumed non-significant, because the reason we sometimes tell this, because we can move the decimal point and change the format of the number, because we can write the same number as a scientific number when these zeros do not make any difference. At this point those matter, but at some point those may not matter. So that's why in some cases we assume that these numbers are not significant. Let's look at a couple of examples. How many significant figures we have here? Four, right? Because all the digits are significant. How about here? So as I said, the rightmost one sometimes you can assume is not significant, because you can move the decimal point and change the number of scientific numbers, so it's 2. How about here? 3, right? It's all 4. Because 0 are in the middle of, in between to another 2 digit, right? How about here? 3. Because you can ignore this one, right? But you cannot ignore this one. Still 3, right? Because the leftmost one and the rightmost one are not significant as well. So how many digits do you have here? All the digits are significant here, because you cannot ignore this one, you cannot ignore this zero. So none of the zeros can be ignored here, because those are in between decimal point and other digits, right? 3, right? Because this zero doesn't make any difference. Again, this zero doesn't make any difference. Leftmost zero doesn't make any difference, right? So let's look at how to round a number. Because a lot of times the number comes with decimal, comes as a decimal with a decimal point, has a lot of digit after the decimal point. So you know, it depends. In case of scientific calculation, we sometimes prefer to have those digits, because if we have more digits, the number is more accurate. But in some cases, we cannot write all the digits. For example, if you have like 10 digits after decimal point, some of the digits do not make that much difference if you ignore it. Okay, because the more you go to the right, the weights are getting lower, 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 right? So let's say there is a digit after like 9 decimal position. And so that one doesn't make any difference much, but still it requires in some sort of scientific calculation, because we want exactness, right? So, but some cases we want to round it up. Let's say I have a number with like 5 decimal digit, and I want to write it with 2 decimal digits. So we need some sort of rounding at that time. Okay. What I do is, we first determine the number of significant figures or the decimal place to which number to be rounded. It will be, you know, it will be mentioned in most cases that, okay, round it to 2 decimal places or up to 3 decimal places. Okay. So all digits to the right of the rounded digits will be dropped. If the digit to the right is 5 or more, change the rounded to 1 or higher. Less than 5, do not change anything. Let me show you an example. So if somebody gives me this number and tell me to round to 3 significant figures, okay, so what I'm going to do is, because I know that we have 4 significant figures here, right? Do you see? There are 4 significant figures, but if I have to make it 3, that means I'm going to change this 5 to 0, right? So if I do that, then since the digit I'm making 0 is 5 or more, right, then I have to increase the last digit before that by 1. So what I did is I changed this 1 to 2 because I'm ignoring this 5, meaning I'm replacing this 5 by 0. If this is like 4, then I would not do anything. I would just write 4, 7, 1 or 1, 0. Okay. If this is 3, 0. If this is 5 or more, then only I change it to 0 and I add 1. Now what happens if it is up to the decimal point, like this one, the next example. Now for an example, let's say somebody gave us this number and we were asked to round it to thousands position. Thousands means 3 positions after the decimal point, right? Up to 4. So I'm going to drop this 2 digit, but look at the first digit here. The sequence of the digit I'm dropping. This is the first digit, and the first digit is 0. If the first digit is 5, then I'm going to add 1 here. But this is not 5. This is less than 5, right? So I'm just keeping it as it is. So I'll just drop everything after this. I'll just keep it 934. Let's try some example. For example, let's say if we have to round the following numbers to 3 significant digits. Okay, this one. Now 3 significant digit means we'll basically stop here and we'll replace these 2 by zeros. Now look at the first digit I'm replacing by 0. Is this more than 5? Of course, right? This is 7. So what I'm going to do is I'll make both these zeros, but I'll add 1 with the last digit. So I'll make it 23700. So the right answer is going to be D. The reason I add 1 with this because the first digit I dropped, I'm saying I replaced by 0, is more than, it's 5 or more. So the right answer is D. 23700. Now let's try another example. How about this? I have to round to 3 significant digits. Right answer is B, right? Because I'm changing 4, 9 to 0, but this is 4. Remember I mentioned it should be 5 or more to make it 1. I'm saying to add 1 with the last digit. So I'll just keep it B, 13700. I'm just replacing 4 and 9 by zeros. 3 significant digit again. So I'll keep up to here, right? But the first digit I'm dropping is more than 5. So it's going to be B, right? How about this one? 3 significant digit. So that means you start from here, first significant digit, second, you'll stop here, right? But the first digit you dropped is 5. So you increase it by 1. So that becomes 0.088. Right answer is B. Right answer is B. Any question here? Okay, another example. Round it to 3 significant figures. So start from left side. We'll basically stop here, right? So the first digit I'm dropping is what? 7. So it has to be 4, right? So I can just write C. Because it doesn't matter I put 0 because those are not, doesn't matter, right? So the right answer is C. Okay, how do I add or subtract the decimal number? Let me show you an example. Right, show this step. Now let's say we have 2 decimal numbers, decimal fractions, and we are trying to add. All I need to do is I'll just do the same math that every time I do. The only thing is I have to align the decimal point. Okay, so to align it, look at this here. After the decimal point we have only 2 digits in this number, but in this number we have 3 digits. So what we did is, since we aligned the decimal point, we have to align it. So I wrote 3 digit, and here I wrote 2 digit, and then remaining positions I replaced it. I just padded by 0. See, it doesn't matter. You can assume 0, but sometimes to be simple, we just add zeros, and then we just add, just like the regular whole numbers. And every time we are passing the decimal point, we put a decimal point here. So addition is just like the regular addition, and subtraction is just like the same. We align the decimal point, and then we subtract, just like how we do. And then we, some positions we just replace it by 0, because we just have to make the same. We just to make the same number of decimal places after the decimal point. How do I multiply? Multiplication doesn't require any sort of alignment. The only thing is, for an example, we're multiplying 2.5 times 0.25. Now, just think about the significant digit here. In the first one, the significant digits are 2 and 5. Without the decimal point and write the first number without the decimal point. In the second number, the number is 0.25. If you ignore the decimal point, what is the number? 25, right? So both numbers become 25 if you ignore the decimal points. Let's multiply them. Once you multiply, the answer becomes what? 625, right? 25 times 25. Then, once you get the answer as a whole number, check how many decimal places you get in both of your numbers. So, if you look at both of the numbers, in the first number you had 1 decimal place, right? In the second number you have 2 decimal places. Meaning in total you have 3 decimal places. Now, you have to write this number such that you have 3 decimal digits. So you have to place the decimal point here so that all these 3 digits is right after the decimal point. Okay, because you have to have that many digits right after the decimal point. Let's look at another here. So for an example, if you look at this example, note the decimal point. Both numbers become 12. I multiply both. So both numbers become 144, right? I'm saying after the multiplication. But if you look at the original numbers, you have 2 digits here after the decimal point, 3 digits here after the decimal point. So in total, you have 5 decimal places. But your product of the multiplication becomes 144. So how do you make it 5? Because you have just 3 digits here, right? So add 2 zeros at the beginning and then put a decimal point. See, do not add zeros at the end, because remember the zeros at the right side of the number after the decimal point doesn't make any difference. We add zeros at the beginning of the number, and look at how many digits we have right now. 1, 2, 3, 4, 5. Because we have to make 5, right? Because the total decimal digit in the original numbers are 5. Let's look at division. How do I divide the decimal numbers? So, for an example, to divide decimal numbers, what we do is we move the decimal point at the beginning. Okay? So, for an example, let's say this is the number you are dividing. Okay? So, you have to assume there is a decimal point and there are zeros, right? So, let's say we are dividing 35 by 8. How do you divide it? So, it's 35, you are dividing, so you assume there are zeros, right? Because you can always assume that, but those are not significant though, but you can always assume that. So, you start, okay, 8 times 4, 32, and 4. But now you need some zeros, right? You need to bring down 0, but look at this. to bring the first 0, you are just passing the decimal point. So the moment you pass the decimal point, you have to add a decimal point in your quotient. Now you have 40. 5 times 35 minus 2. 3 times 8 is 4. So you don't have to care about anything. You just do the division. That's right, the regular division. 6, 0. So 7 times 8 is 57. So you can keep, 6, 56, and then 4, 0, 5 times 8 is 4, right? So be careful when you pass the decimal point and bring the next digit down, then you just put the decimal point in the quotient. Similar is here, okay? But in some cases, you might have decimal point here. That's a little bit tricky because some people do not want to deal with these. You can, but what most of the people prefer is they move the decimal point one places, how many places they need, get rid of the decimal place in the divisor. Okay? For an example, you have 2.4 in the divisor, right? So what you can do is, if you move the decimal point one position to your right, you can get rid of the decimal point because that becomes a whole number, right? 24. Okay? But you cannot just move the decimal point, from the divisor. What you need to do is, you have to move the same number of decimal point, the divisor and dividend both. So what we did here is, look at this. What we did is, we move the decimal point from here to here. And similarly, we move decimal point from here to here. One position. You might have to move it 2 positions, sometimes 3 positions, but you have to be careful because the number of positions you are moving, the decimal point in the divisor, same number of positions you have to move the decimal point in the division as well. And then rest is it. So the idea is you will get rid of the decimal point from the divisor. And the rest is just like that, previous division. Okay? The moment you will pass the decimal point, because here, look at this. If I just start the division, the first thing I will do is 24 times 2 is 48. But to do the first 48, I'm passing the decimal point. So that's why I start with the decimal point at the beginning. And then I'm writing 2. And the rest is just like the regular division, right? So, remember the last lecture we were talking about the fraction. So we can convert every decimal fraction into fraction. Here are some examples. Like for an example, what we do is, for an example, we have 0.8. We can just write 8 here, and then we'll just write 1 following by some zeros. But we'll put as many zeros as we have digit in the original number. So how many digits you have after the decimal point here? 1, right? So that's why I put 1 0 here. And then once we have these, we just make it simple. Remember the lowest term, last class we learned that to get the prime factors and then cancelling out. So we did that, get this one. Similar is here. We have 3, 6, 2, 5. So 3 is the whole number. Keep it as it is. So then I just write 6 to 5, and we have 3 digits here, right? That's why we have 3 zeros after the 1. And then we made it simple. We just did the prime factors and cancelling all of those, and then we got rid of, this is the simplest one. And if you look at this one carefully, this is a mixed number, right? But you can convert it to improper fraction if you need, just like how we did in the last class. But we always prefer to do it in the lowest term, no matter how it is. We can do the reverse one. So all you need to do is just divide. For example, if you need to do this, for some people, do it in a different manner, but the best thing is if you divide. So what you need to do is divide the numerator by the denominator. Okay? And to do the division, for an example, how do you divide 1 by 4? To do the division, plenty of zeros. Then you will start with 1, you can assume there are plenty of zeros by 4. So 4 times 2. But the first thing is that for the first time you will be basically passing the decimal point. So you will start with the decimal point. This is your rate. So, and then you will have 2, right? 10 minus 2. Then again you will bring down another 0, 5 is 20. That's how you get 25. So you just divide. Here, the next example, you have 5 and 3 over 3. So the 5 is a whole number, so you can keep the 5 as it is. And then you just divide 2 by 3. But some of the division, in this case, for an example, some of the divisions never stop. It will keep going. So you do not have to do that long, because most of the cases we will tell that, okay, round it up to 3 digits or round it up to 4 digits. So you will stop at some point and round it, because we will keep going all the way to 6. Let's look at a couple of examples here. So if I change this decimal to fraction, okay, the first thing would be 6 over 10. But this is not probably the final answer, because this is not in the lowest term, right? Because 6 over 10 can, we just don't want the simplest form here or lowest form here, but we can do it lowest, right? How do I do it lowest? 10 I can write 2 times 5, and 6 I can write 2 times 3, 3 over 5, right? Questions. Sometimes you may not have the lowest term, so choose whatever is best for the answer. But if you have the lowest term, you must have to choose that. How about this one? 7 over 100, right? Why it is 100? Because you have 2 digits after the decimal point. So this is 100, not 10. So the right answer is B. 73 over 1000, right? Because you have 3 decimal digits. So the right answer is D. Is the right answer D? Do you see? Any questions? Okay, let's look at another example. 1.3. See, first of all, 1 is a whole number digit. So, 1 is a whole number. We'll have to take care of 3.3. So I can write 3 over 10. But now this becomes, so it's 1, 3 over 10. It becomes a mixed number. But look at the answer you have in the list. Your answers, all of the answers look like as a fraction, right? Not mixed numbers. So we have to convert the mixed number into fraction. Remember, if I convert the mixed number into fraction, most likely the number will become improper fraction, right? Otherwise, just multiply this to, right? 1 times 10 and add 3. That becomes 13 and keep the denominator same. So it's going to be 13 plus 10, right? Is 8, right? Last question, 12.35. What is the right answer here? So 12 is a whole number, then 35 over 100, right? 35 over 100. But you can do it in a lot of different manners. So one option is just keep it as it is and convert it to decimal fraction, improper fraction. So 12 times 100 becomes 1200, right? And you add 35, right? 12 times 100 plus 35, and then you write it here, which is 1235, right? So the right answer is can get a lowest term for this question, if you get a chance, you can lowest term. Because there are prime factors, you can cancel out everything, and then everything get reduced to the prime. Any question here? Okay, so let's go to the quiz section. There are 2 quizzes for this chapter. Okay? Chapter 3, quiz 1, and chapter 3, quiz 2. Once we are done with those 2 quizzes, we are done for today. Okay? And I know that there is a problem in the last chapter, because most of you have not seen the image of the question. So I'll add the point for this question. So don't worry about that one. I know that. That's the last question, right? Because it doesn't have the image. You can, but I'll adjust the point. But in case you did not select that, if you see, selecting the answer, if you just keep trying, you will know exactly which one is the right answer. But since you do not know the question, it's just like, but I'll adjust the point. If you don't have, I'll check. I just told everybody that I'll adjust the point. Okay. So let's go to the quiz section, and there are 2 quizzes. Let's finish those. When you are done, these 2 quizzes. We'll talk about the chapter 4 in the next class. And just as a reminder, we have a test 1. Just write 2 weeks after from today, okay? 2 weeks from now. It should be February 20th, right? Or test 1, which will cover everything from beginning to next class.